brackets. Oh my god. I'm always so excited to start these videos because I get to spend some time with my favorite people. Whatever, that's creepy. Alright, anyway, here we are. We are on Algebra 1, Algebra 2, Algebra 2, Chapter Unit 1-2. Wow, this might be a long one. I might need some more Dunkin' Donuts coffee because it's empty. I'm going to have to go get some more because it's empty and I might need it. Anyway, day 2. My name is Mr. Krause. For now, you can call me Mr. Key. I am the one half of the Newman Krause Infinity.com duo. If you want to find most of our stuff, you can go to nkinfinity.com. Links to all my videos, or you can just go to the YouTube channel. There will be a link in the show notes. If you haven't hit the like button, hit the like button, hit the subscribe button. Let us know what you think. Leave us a comment. Please don't yell at me and tell me I'm bald and ugly and loud and obnoxious. I don't really care. I really don't. Let's get started. Day 2. Hopefully this video is shorter than day 1. Day 1 took forever. Still talking about domain and range from yesterday as a little bit of review. Remember, we've got domain and we've got range. Domain are the input values, and these are the output values. So you're going to take your domain, you're going to put it into your function. It's going to go, these are the input. You're going to put it input. Wow. Maybe not. Sorry. Can't draw. Can't write today. Sorry. Input values. And what pops out is the range, and it's our output values. Okay? So, very quick warm up. Probably go over in class in about 2 minutes while your teacher's checking your homework to make sure you did it. And I know you did it because you're good students. If you're not, you should be. Domain are the x values. So if I want to list them out because they are discrete numbers, I will list them out like this. 120, 240, 260, 130. Oh, I should put those in order. That would look more professional. Notice there's two 120s. It's that same table from yesterday. So we're not going to list that twice. 120, 130, 240, 260, and 295. I'm going to count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, but the repeating 120s. Now let's do the range. Now the range is going to be a little bit trickier. The lowest one is 882. And then we go to, 929? 929, then 930. I don't know why I picked such big numbers. And then 977. There's no repeating, so I got to list them all. 988 and 991. Hey, there's my big doggy. Saying hi to everybody. So, yes, this is not a function because we have repeating x values. So this is a domain. This is a relation, but it is not a function. All right, so the domain here, we've got to list out all the x values. So 1, 2, 3, 4. That's it. 1, 2, 3, and 4. Now, the reason I didn't list out 5, 6, 7, 8 because there's no points up here. So I can't list out 5, 6, 7, 8. Range. Notice I'm using nice curly brackets. 1, 2, 3, 4, and 5. Now you'll notice that I didn't list out 2 twice, even though there were 2 points. And I didn't list out 4 twice, even though there were 2 points. I only have to list it once. And this is not a function because it fails the vertical line test. Remember that from yesterday? All right, let's talk about continuous function. Here we have this function y equals x plus 1. You should all know what this looks like. It is just a line that has a y-intercept of 1 and a slope of 1. Now, one thing that's very difficult for those of you that don't watch my videos on a regular basis, but we'll start, is that graphing and drawing lines almost impossible because I'm trying to look at the screen and graph. So to hit all those points is really, that's ridiculously awesome. All right, right now I want you to hit the thumbs up down there. Give this baby video a thumbs up just for that line right there. All right, so that's the line f of x equals x plus 1. Notice this is a continuous function. A continuous function just basically has arrows. It's going forever somewhere. It's got an uninterrupted domain and range. It just keeps going forever and ever in one direction, forever and ever in the other direction. So identify the domain and range. Well, the domain goes from negative infinity to positive infinity. So one way I can represent that is from negative infinity is less than x is less than positive infinity. Now notice I use less than. Do you ever play the I hate you infinity, or I hate you infinity plus 1, and then I hate you infinity plus 2 game, or I hate you infinity, and then I hate you infinity, and then I hate you infinity. You get it? You can't ever get... Infinity is just the end. But you can never get there because you can always go one more. And then you can go one more. And then you can go more infinities. And then more. It never ends. It's never end. It's a dumb game. So, but I am going forever and ever in this direction. And I am going forever and ever in this direction. Excuse me, that should have been... I am going forever and ever in this direction and forever. So domain is all reals. But I'm also going forever and ever up, and I'm going forever and ever down, so the range is all reals. Now this notation is called inequality notation or standard notation when I use this. Next page, we're going to talk about the two different types of notation that you are responsible. Inequality is also called the standard notation. Most teachers will probably just call it inequality notation, but standard notation. When you do that, you're going to be using less thans and greater thans, or less than or equal tos, or greater than or equal tos. Now, if you remember from 9th grade, for interval notations, we're going to use, if we have less thans without equal signs, we're going to be using parentheses, whether you use the front parenthesis or the back parenthesis. And for these little puppies right here, we'll be using the brackets. So if I was to come back up to the problem we were just working on before, and I wanted to represent the domain, this is the domain. By the way, I forgot to label it domain and range. D and R is probably good enough for domain and range, but the way I had it was not good enough. So you guys should have called me out on that. Damn, thumbs down now. No, don't hit the thumbs down. Don't hit the thumbs down. Makes me look bad. Take that off. Hit the thumbs up. Makes me look good. That's my partner in crime getting back to me. At any rate, I could have written this like this. I could have written it out nicely. Ooh, let me get away from my big fat head. Domain. And I could have gone negative infinity is positive infinity. Now, why am I choosing parentheses? Well, I'm choosing parentheses because these are just less than. They do not have the equal to. And the range then would also be the same thing. Negative infinity to positive infinity. Okay, so that's interval notation and standard notation. You must know both. You must be able to go back and forth between both. So we're going to do a little fun. Have a little fun here. Before I start this, because it's going to take a few minutes, I'm going to take a quick pause. Be back in a flash. You won't even know I'm gone. Okay, here we go. I got to stop periodically, otherwise the voice does not match the video. It's really annoying. Whenever the voice doesn't match the video and somehow they get out of sync, it's kind of annoying. So that's why every once in a while I have to stop just to kind of save that part of the video and get back. Video, believe it or not, is a crazy hog on the calculator. All right, so I'm going to draw a number line. I'm going to graph this sucker on the number line. Ooh, that line's kind of terrible. All right, so we go from 2 to infinity and beyond. Everybody loves Toy Story. So this is 0, 1, 2, 3, 4. So I don't know if I've told you about my 4s, but my 4s are crazy. I don't know what it is about 4. I can't. Oh, see, I got to take my time. So notice it has it equal to here on the positive 2. So that means we're going to do a closed circle. Oh, yeah, you got to remember your 9th grade algebra. And we're going to positive infinity. So we're going in that direction. Now, that's the way I do it. Some of your other teachers might do it like this. Let me do it with this yellow. They might do like, make a nice thick yellow line there, maybe a nice thick blue line. I don't know. I don't like that. I like to do it with just an arrow above and do it that way. So then we're going to do it in interval notation. Now, on the 2, we have an equal to, so we have to use a bracket. On the infinity, we have not equal to, and you can never equal infinity. So anytime you write an interval notation with infinity, you have to use a parenthesis. So it would be 2 comma infinity. All right, this one's going to be almost the exact same thing, except this time on the 0, 1, 2, 3. On the 0, we're going to put, on the 2, we're going to put an open circle, still going to the right. Well, the only difference between these two graphs is right here. One says equal to, one says not equal to. So this should be parenthesis 2 comma infinity and beyond. Just got to say that. All right, and now we're going to just going in the opposite direction. So we're going to have basically the same graph, 0, 1, 2, 3, closed circle at 2, but in this case 2 is the biggest number and we're going off to negative infinity, so we're going to draw our arrow going that direction forever and ever. Remember, we can never reach infinity or negative infinity, and the highest number is 2, and we use the bracket. One of the things I like to tell my kids is the small number always has to go on the left and the big number on the right. So negative infinity is as small as they could ever get, so it always has to go on the left. Positive infinity is as big as it can get, so it always has to go on the right. Let me move up so my big head's out of the way. Again, this is going to be the same graph as the last one, except we're doing it in fancy blue. 0, 1, 2, but now we're going to do open circle going to the left. That means negative infinity all the way up to positive 2 parentheses. Now these ors are a little bit tricky. In standard notation or in inequality notation, we use the word or. We're going to use something a little bit different in interval notation. So we're going to first draw our number line. Now if I didn't have this over here, and I just did this, that would be from negative 2 to 0, or negative 1, 0, 1, 2, 3. So if I just had this part, let me do it in black. From negative 2 to 1, negative 2 does not have an equal sign on it. Notice no equal sign, so an open circle. And at 1, it does have an equal sign, so we use a filled in circle there. And we connect those two dots. Now, this part, but I do have it, so I have two parts. Anytime you have an or, you're going to have two parts. So I got this one that says, oh, start at 2, open circle, because it doesn't have an equal sign, and we're going to go to the right. So that's the graph of what I just did. But now we're going to do it in interval notation. And in order to do it in interval notation, you have to take it in two parts. We've got to take this part, or then do this part. So we're going to just do this first part first, right here. The small number is negative 2, and the big number is 1. So I always start with the numbers. Negative 2, small number. Big number is 1. Then I go back. Oh, open circle, or no equal sign, parenthesis. Oh, closed circle, therefore bracket. Then I'll do this one. Come back to what we got to put in the middle in just a second. We're going to do this one. It's the small number is 2, and the big number is way over there. It's infinity. Infinity always has to go on right, positive infinity, and you can never reach it, so it's a parenthesis, comma. This is an open circle. It does not have an equal sign, so we're going to put a parenthesis here and a 2. Now what goes in the middle, the symbol for or that goes in the middle is a U. It stands for union. Union means we're going to put these two things together and they become one set. Okay? All right, so now number line. So we got -2, -1, 0, 1, and 2. So equal to -2, so solid circle, and we're going left towards negative infinity. We're getting less than that. Oh, closed circle at 1. Going this way. Notice there's an or. We're going to take each piece individually. Let's take the left piece. It goes to negative infinity. It stops at -2. You can have an equal negative infinity, and we had an equal sign, so it's bracket. Union. Anytime you have two pieces, one on the left, one on the right, it's always going to be a union. Bracket at 1 because it's equal to, and it goes off to positive infinity, and we can never reach positive infinity. All right, that's that. All right, before I tackle this page, I will stop, and I will be right back. Don't miss me too much. Okay, all we're going to do on this page, and there's a lot going on here. There's a ton of space here, but it's a pretty easy page. All we're going to do is drink some Dunkin' Donuts coffee because it's delicious. I need a sponsor. Dunkin' Donuts would be nice. All right, guys, if you haven't hit the subscribe button, hit the subscribe button. If you haven't hit the like button, hit the like button. Let us know. If you want to leave a comment, leave a comment. All right, let's get going. So this, by the way, is this a function? Yes, it passes the vertical line test. Remember, I can draw a vertical line in anywhere, and it will pass. I hate the color green. Let's go back to cool blue. So when we're talking about domain and range, we're talking about what is the leftmost number, what is the rightmost number. Well, the leftmost number, if you think about it, it's going forever and ever and ever in that direction, and forever and ever in that direction. So the leftmost number is negative infinity, and the rightmost number is positive infinity. And let's do this in interval notation because it's a lot easier. So what we'll do is we'll say, okay, from negative infinity to positive infinity. Notice I use two parentheses because you can never equal infinity. Now, down and up are the range values. What's the lowest down? What's the highest up? Well, let me grab a different pen for that. We'll grab cool purple. Here's the smallest y value down here. So if you go all the way down, the lowest number you'll see is a 0. And then it goes forever and ever and ever up. So the highest number is infinity. So small number on the left, big number on the right, you can never equal infinity. Now we have to decide, are we going to use a bracket or a parenthesis on the 0? And we come back over here, it's a filled in circle. And if I erase that, you'll see it's a filled in circle. So we'll use a bracket. Oh, we can ball that. Lower a little bit. All right, example 3. What happened to example 2? Oh, example 2 is on the other page. Sorry. Anyway, leftmost number, negative infinity. Rightmost number, positive infinity. Wow, there's a surprise. And you'll find a lot of domains are negative infinity to positive infinity. It's only in the range where we get the restrictions. The lowest y value is, I don't know. Well, let's take a guess. Oh, there's my Star Trek going. Somebody's texting me. Oops, an email. So the lowest value is, I'm also the athletic coordinator for our district, and that's our swim coach telling me about practice. Woohoo, so exciting. So the lowest, furthest down we go to is like negative 2.2, but it's going forever and ever up, so that would be positive infinity. So from I would say negative 2.2 comma infinity. You could argue this is a parenthesis because you're not really sure if it's rational or not. But if we're going to say the lowest value is 2.2, for this particular problem, we'll assume it's rational. By the way, is this a function? The answer, of course, is no. It does not pass the vertical line test. So the leftmost number is negative 3. The rightmost number is positive 3. Negative 3, positive 3. Notice it hits both, so we'll use brackets. The lowest it goes is -3. The highest it goes is +3. It hits both, so we'll go -3 to +3. Boy, that was a simple one. Notice it goes forever and ever left, and it goes forever and ever right. So that would be -infinity and +infinity. Parenthesis, -infinity, parenthesis, +infinity. Now, here's the tricky one. This one's kind of tricky just to look at, but you got to imagine out there at infinity. See, it looks like it might stop at 2. But in effect, what it's doing is it just keeps going up and 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 up. This is going to go up forever. So it actually is going down to -infinity and up to +infinity. Just like in this direction, it will forever and ever and ever and ever go down. It may be going real slow, but eventually it's going to get to -infinity, right? Wrong! You can't get to infinity because you can always go a little more. So you'll never get there. You just keep trying. Don't. You'll be there all day and the rest of your life and your kids' life. Well, you won't have any kids because you'll still be trying to find infinity. Can't find infinity, you have kids at the same... Never mind, not talking about that. We'll just ignore that. I'll be back, kids. Oh, all this infinity talk has made me so happy. Oh my God, more examples! I turn the page and I'm like, more examples for you and me to practice. Oh, could math get any more longer? More longer is not English. Anyway, let's get moving. This won't take very long. We are going to talk about what's called piecewise functions. I know you've learned them in 9th grade. Piecewise function basically just means there's a little piece here, and there might be a break, and then there's a little piece here, and there might be a break. We call those jumps or holes, and you'll learn a lot more about those points of discontinuity and non-continuity and all that cool stuff in pre-calc and calc. But for now, you just need to start to recognize holes and jumps and weird functions. Okay, so these are weird functions. It's kind of like me, a little bit weird. All right, so the most left we go is right here, -1. So -1's the most left we go. The most right we go is +3. Now watch along, because this is not a continuous graph. Or is it a continuous graph? Are there any holes or breaks? Are there any places where it doesn't count? And it looks like we have no holes, so I would choose -1, 3. Range. The lowest range y value down here at -1, and the highest y value is up here at +1. So, and I look up and down, am I using every value between -1 and 1? And I am, so I'll go -1 to 1. So this one's not too bad. All right. Do I go forever and ever and ever to the left? Yes, -infinity. Do I go forever and ever to the right? Yes, +infinity. But are there any holes? And I'm a little concerned right here because I see a hole at 1. So I'm going to ask myself, can x equal 1? If x is equal to 1, is there a point on the graph? And yeah, there is. Even though we have this jump up to here, this is still a point on the graph. So yeah, there is no x value that's not being used. Now, if this was an open circle here, if for some reason this was just an open circle, then you would have less than 1 and greater than 1, but not equal to 1. And I'd have to write my range or my domain slightly different. But in this case, I can write -infinity. Notice I'm using parentheses because you can never, ever equal infinity. The lowest number I'm going to go is 0. And the highest number I'm going to go is +infinity. And once again, are there any breaks up and down? So from 0, you would think, oh, wait, look, there's a hole here. But notice there's still a point here. So yes, I can have a y value of 2. It's just over here. So this is from, but we can equal 0. So we have to put a bracket at 0. 0, comma, +infinity. All right, so this one's freaky diggy. So let's see what we got. My leftmost number is -2, and my rightmost number is +2. Now I got to decide, are there any breaks left and right? So as I travel from -2 to 1, so So from -2 to 1, I've got all these values. At -1, oh, it pops up here. It jumps up here. But I still have a value at -1. And it goes all the way over to 0. But at 0, it pops and jumps up here. And I still have a value at 1. And, yep, still have a value at 1 here. It pops up here. And then, oh, open circle here. So I am, in fact, using all the values from -2 to 2. But not 2, because notice it's got an open circle there. Now, this is called a step function. A lot of people call these step functions. The lowest number is, in fact, -2, and the highest number is, in fact, 2. But notice none of these values in here are being used. Right? There's no graph that goes from here to here to here to there. There's no continuous line to graph up and down. You don't see any smooth line going up and down. So the fact of the matter is, y can be -2. Y can be -1, y can be 1, and y can be +2, but nothing in between. So I can't use normal notation because these are what's called discrete values. One number, then a number, then another number, then another number. So what we have to use is set notation. What is the range? In this case, we're going back to like what we did yesterday where we just had certain discrete numbers. So the range in this case is -2, -1, 1, and 2. Those are the only values that x can be. No rational or irrational numbers in between, nothing. Just those 4 values. All right, we're almost done. That was kind of a tricky one. You got to be careful with those step functions, with especially the range. All right. We got 3 more questions. Choose an appropriate window based on the graph. Now, these can be different. Now, what I mean by an appropriate window is if you were going to graph this on a piece of graph paper, or if you were going to use your graphing calculator, how would you set up your window on real-life problems? Most real-life problems don't have negative values, right? If we're talking about time, there's no negative time. We're talking about distance. Generally, there's no negative distance unless you are set your starting point up here and you have negative distance up and down. But generally, there's no negative distance because you really can't have a negative distance. Distance is just a number positive unless you add direction in there. Another story. Welcome to physics class. Let's say we have a baby bird in its first flying lessons. Now, have you ever seen a baby bird on its first flying lessons? If this is your tree, and I know what you're thinking, why didn't you become an art teacher? I know that's what you're thinking. And this is the ground. So your bird's up here in their nest. Yay, mommy, yummy, what? You gotta fly? Oh. So, I know you're thinking, wow, Mr. Krause, you are an artist. All right, don't tease me, okay? I don't like to be teased. But a bird comes out, flaps its wings, and crashes down to the ground, right? That's its first flying lesson. So, the domain in this case, notice it's h of t, where h of t represents the height, and t is the time. Okay, so let's talk about, now t is the domain, so we got to describe this. Domain is our t values or time. So what would be an appropriate time? At the very second it's about to take off, that would be 0 time. So 0 certainly would be our beginning. Now, what would be an appropriate time in seconds for a bird? Well, let's hope it's not at the top of a redwood where it takes like 10 minutes to fall and hit every branch on the way down and pop on the bottom. I'm hoping the bird didn't do that. That would be not very nice. But I don't know. How long does it take a bird to fall down out of a tree? Maybe it took off and flew a little bit and then crashed down. I don't know, but I'm going to say maybe 10, 15 seconds. I don't know. Let's go with 20 seconds. You can argue that any way you like. Maybe 20 seconds. Maybe that would be a good window. Maybe you decide this bird's pretty good. It flies, gets tired, and then crashes. But generally not. Range value. Okay, so let's talk about range. Range. What would be a good range value? Well, unless you're true, you've got a psychological, bird that's crazy, you might be 100 feet in the air. I don't know. The problem didn't state. So now you have to decide. I don't know. But we do know one thing. This bird's going to eventually probably hit the ground. So 0, because it's going to go flap, 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 hit the ground. So its height at the end, or h of t, or range, will be 0. I don't know. What does it start out? 120 feet? 200 feet? I'm going to go 100 feet. I'm going to say no bird would put their little baby more than 100 feet in the air for its first flying lesson. I don't know. Again, you could argue that. Generally, many problems will have a more descriptive idea about that. I'm going to have to stop. I'll be right back. So here's my dad. See the big nose? I'm sorry, Dad. Didn't mean to make fun of you. All right, students that are between the ages of 14 and 15 have certain restrictions on what they can do during the week and what they can do outside of the week, or during school and outside of schools. If you're 14 or 15, you may not work more than 3 hours per day, Monday through Friday, and you may not work more than 18 hours per week. So if school's in session and you're 14 or 15 years old and you get hired by somebody, you can't work more than 18 hours. That's just the law. That's just what it says, which 18 hours is way too much for a 14 or 15-year-old. You should be working on schoolwork. I know. Anyway, they may not work more than 8 hours per day when school is not in session. So if a student works at a job where they're paid minimum wage of $8.75 per hour, what would be appropriate domain and range for the function W of t? Now, before I can answer that, I got to answer one very specific question. Is school in session, or is school not in session? If school's in session, the most I can work is 18 hours. All right, so in this case, function of time worked during a school week. So W of t, remember, stands for my wages. How much money am I going to make? And T is my time, and this, of course, is in hours. So because it's during the work week, my domain, which is my time domain, is going to be between 0 and 18 hours. The most I can work is 18 hours. My range is going to be, well, if I don't work any hours, I don't make any money. So 0. But the range is got to be how much money I can make. And how much money I can make is 18 hours times, how much was I making? $8.75 an hour. $8.75 an hour. I could have picked less obnoxious numbers. So I come over to my calculator and I go 18 times 8.75, and I get 157.50. Shoot, I keep going the wrong things. 157. So this is equal to 157.5. Don't put 5 there. Put 50. So the most amount of money I can make is $157.50. So that would be my range. Now, what if it was not during a school week? What if it was during summer vacation? Or what if it was during spring break or holidays? Well, then it said you are not allowed to work more than 8 hours per day. But that's it. They may not work more than 8 hours per day. Okay. Well, if that's the only restriction that New York State puts on you, 14 or 15-year-olds old, that when school's not in session, you can't work more than 8 hours per day. Well, I could work 8 hours per day times 7 days. I could actually work 56 hours in a week. So my domain, if school was not in session, would be between 0 and 56. And I believe then my range then would be, let's see, I got a 56 times 8.75. I think it's around 490. 56 times 8.75. This one I didn't figure out. 490. Oh, it is 490. 490. So in this case, my range then would be between 0 and 490. But again, they didn't ask about this. They asked about during a school week, so that would be these answers. All right, Dominic and John are practicing for their sectional baseball game. If the two boys are throwing the baseball back and forth, it's such cute. I don't know who's this. And h of t. So remember, h of t, which is my range, is the height. So you got to think about what the height would be, and t would be time. I'm going to guess this is in time in seconds. Yes, in seconds. Okay. So Dominic and John are practicing for a baseball game. If two boys are throwing a baseball back and forth. Okay, so I can throw a couple of different kind of balls. I can throw a line drive, but if we're playing catch, you could argue that my height, well, let's talk about time first. If I got two guys throwing a ball back and forth to each other and I want to talk about my domain, I mean, how long is the longest a ball could be in the air? 1001, 1002, 1003, 1004, 1005, 1006. I don't know. Can a ball be in the air 5 seconds? I doubt it. But maybe. So I don't know, maybe probably won't want to restrict my, certainly when the ball, just before the ball's thrown at 0, how long could it be in the air for? I don't know, maybe 5 seconds. Maybe 5 seconds would be the most. Maybe you could argue 6, you could argue 4. I don't know. But certainly if you wrote 12 there, a ball that's thrown for 12 seconds, go out and try to throw a ball as hard as you can and count. I'm going to guess you don't get to more than 3. Good baseball players, maybe they can get to 5 seconds. I don't know. But certainly 10 would be stupid. 12 would be stupid. You put 100 there, you'd be like, what? Why do I need 100? Dumb. Okay, so range. So range is, in this case, the y value, how high up and how far down it can go. Well, if I'm throwing a baseball and I'm starting here, it's probably, I don't know, if you have a short guy, maybe the shortest guy throwing a ball, leaving his hand would be 5 feet. That would be a really young kid throwing the ball, maybe 5 feet in the air. And I could throw a line drive, which would mean it'd stay at 5 feet, or I could throw it really high popper in the air and it could come down. So I don't know. What's the highest a kid can throw a ball? Maybe 50 or 60 feet? I don't know. To be safe, maybe 50? I don't know. Somewhere around there. Certainly wouldn't want to put 200 because that would be dumb. I mean, I get, could you throw a ball 200 feet? Nobody can throw a ball 200 feet in the air. That's just not possible. You can launch a ball 200 feet in the air, but that would be like with a machine or something, but not throw it. All right, kids, that's day 2. All done. All finished. Yay. We only have like 178 more days to go. Oh my God. Man, this is so much fun, especially when you do it every single day. All right, kids. Catch you on the flip side. Hit the subscribe button. Hit the like button. Send us an email if you got any questions, or you can visit us at nkinfinity.com. Or if you like, it's a little easy to remember. There it is at the bottom of your page, algebra2cc.com. Catch you on the flip side. Bye.